Welcome to our quantum deep dive on the topic Quantum Processing Unit, QPU.
Today, we're stripping away the noise. Relying entirely on the authoritative research of Jörg O. Schneppat, we are deconstructing the architecture, the operational reality, and the genuine strategic value of quantum hardware.
Schneppat's work demands that we completely abandon the science fiction hype that tends to infect these quantum discussions. Look, there's no magic here. There is only physics, extremely precise engineering, and cold mathematical reality. So let's look at what a QPU actually is.
Our roadmap for this explainer is strictly clinical. We'll start by defining the QPU, then move beyond classical logic, examine the architecture, look at the QPU as a hybrid accelerator, and finally discuss its strategic and economic significance.
Section 1. Defining the quantum processing unit, the quantum core.
We absolutely must establish the physical reality before we even touch on applications. A quantum processing unit, or QPU, is not just some faster microchip. It is the exact physical location where quantum mechanical systems are controlled, prepared, altered, and measured. It's the absolute core where the algorithms actually execute.
To really grasp the QPU, think about the device you're using right now. Classical processors rely on bits, right? Rigid deterministic logic gates holding a stripped 0 or 1. The QPU, however, operates on qubits. Before measurement, these qubits exist in a probabilistic superposition of states. They simply cannot be reduced to basic binary logic.
Section 2. Beyond classical processor logic. Why it's not just a faster chip.
Let's definitively dismantle a common misconception here. A CPU processes logic step by step. A GPU handles massive parallel operations. A TPU pushes tensor math for neural networks. But a QPU, it operates in an entirely different mathematical dimension, a Hilbert space. Its operations are realized through complex quantum gates and microwave pulses, not traditional silicon logic. We also need to correct a very pervasive, highly inaccurate illusion. A QPU does not act as some parallel universe machine that magically tests all possible answers at the exact same time. That is pure fiction. As Schneppat clearly points out, it relies on carefully orchestrated interference. It amplifies the likelihood of desired results while canceling out the incorrect ones.
Section 3. The architecture of a QPU and the physical paradox it presents.
Actually constructing a QPU introduces a brutal physical paradox. You see, qubits are incredibly fragile. They require extreme isolation. We're talking vacuums and temperatures colder than deep space, just to prevent thermal noise from destroying the quantum state. Yet simultaneously, these isolated qubits demand continuous, highly precise external control from microwaves or lasers to actually compute anything.
Schneppat notes a crucial reality here. A QPU cannot be operated in isolation as a standalone processing unit. It requires classical control electronics. A quantum shape just sitting on a table is nothing more than useless glass and metal. It requires a massive infrastructure of classical machines to generate the signals, maintain that deep freeze, and read the incredibly faint outputs.
Section 4. The QPU as an accelerator within a hybrid loop.
This brings us to the actual operational reality. It's a tightly integrated hybrid loop. Step 1. Classical systems initialize the quantum register. Step 2. The QPU applies the quantum operations and entanglement. Step 3. The end state collapses into a measurable classical result. And Step 4. Classical computers evaluate that data. The QPU is strictly handling that probabilistic middle step.
Which forces a very critical question, one that cuts right through all that media hype surrounding quantum supremacy. Is a QPU actually a universal replacement for classical processors?
The answer from the source text is definitively no. A QPU will not displace classical processors. It will complement them for tasks where quantum phenomena provide an algorithmic advantage. Look, for everyday tasks like running your databases, web servers, or operating systems, a QPU isn't just unnecessary, it is vastly inferior.
It's a strict hybrid division of labor. CPUs will continue to handle the operating systems and general logic. Think of the QPU more like a highly specialized GPU. You only call upon it when a problem requires specific quantum state developments or complex interference steps. It's a targeted accelerator living inside a massive classical machine. Section 5. Strategic and economic significance. Mastering this unforgiving hardware is definitely not just an academic exercise. The exponential state spaces of QPUs offer legitimate, real-world advantages where classical computers simply run out of time and memory.
We're talking about the precise quantum simulation of molecules, deep materials science optimization, and, critically, the factorization of large numbers, which directly threatens current RSA cryptography standards. Because of this, the QPU is a matter of intense strategic imperative. Digital sovereignty and security are directly tied to quantum competence. But as Schneppat emphasizes, true competence isn't just theoretical. It demands physical mastery of hardware control, advanced software capability, rigorous error correction, and deep application knowledge. To summarize this explainer, we turn to Jörg Ove Schneppat's uncompromising assessment. The QPU is not a magical universal machine, but a highly specialized, extremely demanding, and strategically significant computing core. Mastering it is the only way to unlock capabilities that classical physics could literally never achieve. This explainer was built entirely upon the foundational research of Jörg O. Schneppat. For further critical perspectives, additional content, and a factual grounding in quantum technology, you should definitely visit schneppat.de. As we stand on the brink of this hybrid computing era, one massive question remains. When quantum accelerators finally crack the cryptography that secures our entire modern world, who will be holding the keys?
Thank you for listening.
Quantum technology doesn't end in formulas. It begins where our old idea of reality breaks apart. If you want to look deeper, subscribe to the channel. Leave a like, show that you understand the leap. Turn on the bell, stay awake, stay tuned, because the quantum world is only just beginning. Between bits and qubits, the system starts to shift. What seemed fixed yesterday begins to turn anew. Not everything is visible, yet everything acts at once. Entanglement in the shadows, control inside the noise. The future isn't born loudly, it calculates in silence. One click decides whether you keep thinking further or remain trapped in the old logic. Because whoever understands the quantum world sees more than just 0 and 1. Don't miss anything. Listen closely. The future calculates differently.
Subscribe to the channel.
Stay focused.
A like shows that you feel what's happening here. Turn on the bell and
You'll be there when the next quantum leap tears the limits apart. Until the next deep dive, stay awake.